just only, that's the in 3 dimension. But if we are talking about dimensions greater than this, in functions in several variables, so I will be dealing within the +1 dimension. So functions in several variables, that's the general case. If I have f running such that from Rn into R, the graph will be in the dimension n +1. That's this part all about, it's describing this for you. So if you have dr into n, and the function is from d to r, so the input is going to be x1 up to xn, and y, that's the range. So you will be dealing with Rn +1 in the dimensions. If n is equal to 2, the graph will be in R3, like the sphere, like the cone, like whatever we have taken previously. This equation, for example, of course, I can speculate the shape of this function. If I want to speculate the shape of this function, I will have to substitute with a good understanding of the points in the domain. By the idea, do you have any regression on this domain? Do you have a problem with this domain? What? You don't have. Do you have a denominator? Look at it. Do you have a denominator? Yes, I will have a denominator. Is it possible to have this denominator equal to 0?
No.
Sfetin. No. Why no? Because it's an exponential function. صح? So actually this domain is open for all of them in the x, y, and z. By the idea, that's the shape of the function from one of the angles. This is the shape of the function on another angle. That's the shape exactly if you have level curves all around it. Okay? That's the shape of this function. The domain, of course, run in R3 because x will run from 0 up to, from negative infinity up to positive infinity, same way like y, same like z. The shapes here are just only for knowledge, just to increase your imagination about this equation. That's it. Your curiosity, but you are not going to be asked about drawing or something like this. Not like the other part, paraboloid, ellipsoid, and so on. You already have the power to draw them or to speculate the names. Okay, now I will talk about something really very important, which is the level curve. I did pass through it, Ziyad, when we talk about these surfaces. If I make an intersection with any of the shapes, what's gonna be the intersection surface? يعني, so like, if I have an equation of a paraboloid, as an example, of course you know the equation of a paraboloid, which is x squared plus y squared equal to z. That's a paraboloid, symmetric about the z-axis. And its shape, yes, Mr. Ziyad, exactly right. This is x, y, and z, and it will be looking upward around the z, and that's the shape of the paraboloid. Yes? Okay, what's gonna be, Ms. Feta, what's gonna be the level curve at z equal to 3? What to do? All I have to do in order to get a level curve, say that, the one, and really very simple. All I have to do is to replace z by the value of 3. You need to see the level curve at 3. So all I have to do is to replace z by 3. So the equation Ziyad will be, what's the shape of this equation? Or what does it represent? Circle with radius root 3, which makes sense. Z equal to 3, it's a plan. If it cuts this shape, the result will be a circle. Am I right? That's what the level curves represent. What's the importance of the level curves? The importance of the level curves is it represents the shapes inside this this surface. So I can imagine what's gonna happen, and if I put all of these levels all together, I can speculate the shape for the complicated equations. ماشي؟ بص كده. Those are the level curves. This is the idea. All the idea we have to do is to just take the equation and put it to the number that you want to evaluate your level curve. So here you can see how the level curves can appear for any surface. بصوا, that's a surface. If I want to get the level curve, all I have to do, I have the equation z equal x and y. I will put z at 1, I will get this circle, at 2, at 3, at 4, at 5, and so on. So what's going to appear for you, those are the value at f of xy equal 20, f of xy equal z equal 25, and so on. So it will appear to you as cycles. If you look for this graph, y f of xy equal 3x, that's an equation of a plan. صح? That's an equation of a plan. Z equal 3x, it's a linear equation. In 3 dimension, it will be a plan. Okay? So, if I want to have the level curve of this plan at z equal to 4, all I have to do is to replace z, this part, which is z, by 4. So it's going to be x equal 4 over 3, which is just a straight line. All of this makes sense. That's the shape of z equal to 3x. If I cut it by z equal to a certain value, I will cut through a straight line. It will appear to you as a straight line. معايا فاكر؟ Okay. Similar shape, if I have, or similar discussion, that z equals 3x, exactly as I told you. So, if you look for the other equation, which is f of xy, 1 minus x squared minus y squared. Ziad, can you tell me what's the equation of this guy? Z 1 minus صح? So I can do what? I can rewrite it as bringing those two guys to the other side, which is gonna be x squared plus y squared equal 1 minus z. Are you with me?
Yes.
Okay, take negative as a sign, as a command. So it's gonna be x squared plus y squared negative z minus 1. That's the shape, that's y, that's x, and that's z. I will go to z positive 1, and that's gonna be the shape of a paraboloid, as you can see. So it's a paraboloid looking downward. Okay? What do you think about the K, or the level curves? The level curves are those curves. Right? Which are circles. But let me check about the sign. Did I do anything wrong with the signs? Take those guys to the other side, it's going to be positive. Bring z in here is going to be negative. Take negative as a sign. It's going to be negative z minus 1. And that's going to be the shape. Yes, exactly. I believe it is fine. The shape of this guy, it's a paraboloid. That's the shape of the paraboloid, regardless about the direction. So here is the paraboloid that I told you about, and the levels will be around. That's the shape of the equation, a similar equation, more complicated than the ones that we know. And the shapes, بصي level curves. Okay, look, Soraya, imagine that those are the level curves in above each other, each one of them. So actually, if I'm in here, I will have two circles. Just only two circles. You can't see all of this. This is actually all the level curves. But if I cut, I'm using an edge. Okay, if you imagine that you have named a sword or something, and you are cutting like this, so you will have two circles. As long as you go downward, you will start seeing these parts. From one of the angles, you feel that you have one peak or one minimum point. But if I moved the camera into another side, you will have, that's two up humps and two lower humps, as you can see. Okay? So once more, that's the shape. If I draw it in a grapher and I'm trying to be nearer than the origin, those are the shapes. Can you imagine how it is completely different than the original shape that you saw, or the overall shape if I'm moving away from the shape, okay? Those are the shapes, as you can see. Okay, now he sketched some level curves of the function f of xy equal 4x squared y squared plus 1. Of course, it's a paraboloid, and it's looking upward. It's an elliptic one, not a circular one. So that's the shape of the equation. Those are the circular curve, the curves or the level curves. So the shape will be like this if you look at it, once you look from above. Bottom line, if I asked you about a level curve at certain value, all you have to do is to get function in as defined in x and y, replace the value of the function by this guy and solve the equation. Okay, you will be able to get it. Those are the ellipses, as I told you, because it's an elliptic paraboloid. Level surfaces in general, this is how we do it in general. But here in 3 dimension, so actually I will be talking in 4 dimension, okay? So putting this equal to a certain value, I will be able to get the shape. So in this case, I have function equal to x squared plus y squared plus z squared. I need the level curve at 1, 4, and 9. So what I have to do is to replace this guy by 1, which is going to be a sphere with radius 1. Replace this guy by 4, another sphere, a larger sphere, with radius equal to 4. 9 is going to be a larger sphere with a radius is equal to 3, and so on. Okay? So these are the spheres, as I told you. The first sphere with radius 1, the second sphere with radius 2, the third sphere is with radius 3. Okay, spheres with various diameters, those are our spheres, as you can see. If I put them all together, so this is the smaller, the bigger, and the much bigger one. Okay, inside each of them. What's the time now? 10:40. Okay. Those are some problems, some really very simple problems on the level curves on the part that we talk. I will go through them very quickly. Okay, I have a detailed video about them. I may raise it for you on the YouTube. Here is z equal to x squared minus y squared. Here is z equal x squared minus y squared. And c is equal to -1. I need to see the level curve when c equal to -1. If you inserted instead of this guy -1, you will have an equation of a hyperbola. صح? Okay, and for this guy, if I replaced this value by 85, it's gonna be a parabola, and so on. So those are the shapes that you will have if you make these replacements. Those are the shapes. This is actually when you cut. This is how you would see a hyperbola. When you put at -1, this is gonna be the equation of a hyperbola. I've already drawn it for you. So that's the shape in 3 dimension, which is a shape of a hyperbolic paraboloid, if you remember the names. The saddle horse, do you remember the saddle horse? Okay. And this is the shape actually. Once you replace this guy by -1, you will get this equation. This equation is exactly like this one. And this guy, it's an equation of a hyperbola, symmetric about the x-axis, that's the axis in the middle. Once more, for this guy, it's gonna be an parabolic cylinder, if you remember, parabolic cylinder. So if I cut it with c equal to 85, it's gonna give you a parabola. Okay? Just replace this guy with 85, so x squared will equal to 81. So that's the equation that you will be dealing with. Okay? So a level curve is given by putting just c, so x squared plus 4 equal to 85. Solve for x squared, so x squared is going to equal to 85 minus 4. X squared is equal to 8. So all you will have to do if you cut, you will have just the 2 lines equal positive or negative 9 for this. Oh, represent 2 vertical lines, which makes sense. That's the shape of the parabolic cylinder. If you cut with z, you will have these 2 lines. Did you see the 2 edges? Those are the 2 edges or the 2 lines that will appear to you as a level curve. This is also an equation of a plane. If you just replace this guy with 4 or replace this guy with 1 and 5, the first of them is going to be a plane. The second equation, it will be ellipsoids. One ellipsoid at 1 and the other ellipsoid is at 5. That's the equation of a plane. If you replace this guy by 4, this is from another angle. And that's the equation of the sphere. That's a larger sphere at 5. Here, consider the real function of 2 variables, root 1 minus x squared. Determine the domain of f, represent it geometrically. Sketch the graph of the function, you can. See the level curve at 2, and that's an example, if the exam contains a written part. So if I want to cover this part with you, now I've covered the understanding of functions in several variables. You can get the domain, okay? You can name the shape and the graph it, because simply if you look at this equation, Ziad, what do you think this equation will be? It's gonna be z squared, I believe z squared, plus x squared plus 2y squared equal 1, which is mainly an ellipsoid or something. Okay? So the level curves will be an ellipset. Okay, let's try it. Here is the z, that's gonna be the equation. I have the domain, which is 1 minus x squared minus 2y squared. That's an equation of an ellipse. So all the points inside this ellipse will satisfy this equation. That's the domain. Okay? And the outer part is gonna be, that's the domain, boundary, or that's a representation of the domain, that's a representation of the domain. That's the shape that we are talking about, which is sketch the graph of the function, the points inside the circle, the ellipse that we are dealing with. If c is equal to 0.5, all I have to do is to insert 0.5 in here, squaring both sides, and solve for x squared and y squared, which is an equation of an ellipse. As we continue, that's the ellipse. That's the ellipse that will appear in front of you, the ellipse of the base. Okay? That's the shape of the level curve. Okay, blah blah blah, same way like, so that's gonna be an equation of a hyperparaboloid of one sheet, because if you replace this guy by a number, you have two positive axes, one is negative, so it's a hyperparaboloid of one sheet. It depends on the value of c. This is what you are going to see. So if c is equal to 25, that's the shape. By the idea, why it is, when c is greater than 0, okay, I'm talking about the points outside the hyperparaboloid of one sheet. This is the shape of a hyperparaboloid of one sheet. Fatin, what's the difference between this guy and the cone? This part is not a point. Okay, the cone, you don't have a circle like here. Okay, I hope I have another image for this one. This is if c equal minus 25. So once you substitute, you will have this guy. This is for c, if c is equal to 0. This is gonna be the equation that we are dealing with. Those are the shapes of that will evolve from this case. Those are if it is greater than, if it is equal, if it is less than, same way like with the other shapes. Okay. I will stop at here. This is lecture number 4. I will continue, inshallah, after our break, and it will be dealing with the parametric curves. This part is really very important, will be very important, because we will use it down the road in integration to make things easier. All what we are taking at the time being is building a background and tools with us in order to be able to evaluate functions down the road in the second part of our discussion. Okay? So the course is really very connected. Once more, for those of you who are not following us from the beginning, please start from the beginning of the lectures, step by step, and everything will be fine, inshallah. Ms. Seda, can you please stop? Thank you.